Hi. So I'm going to explain what a PI controller is as quickly as I can. So control theory is basically a field that says, it is hard to control position given force as an input. And so when you're implementing a PI controller, you have some input, right? So in this case, position, math that happens, and then an output. In the case of a motor controller, that's going to be the torque applied to the motor. So to explain stuff more simply, though, let's just use this pen as an example. So as we know from physics, if you want to know the force from a spring system, it's going to be K delta X is the force, right? So I go like this and it springs up. Now, that K, that is the proportional portion of the control, right? Because it's a proportional function. So you can imagine as you increase the spring stiffness, it'll spring back a lot further, right? I can push down a lot further and it'll push up a lot further. Now, as for the integrated portion, that's the I, so PI, integrated. If I have a pen like this, gravity is going to make it sag down a bit, right? No matter how strong this spring is, this gravity is going to cause it to not be horizontal. Now imagine that we're looking at where this is and we're like, man, we have really stayed here for quite a while, right? So you have this error in position. And if you time integrate that error, you'll apply a bit more force, bit more force, bit more force, bit more force until it reaches your desired position. So to recap, PI controller consists of a spring, right? So that's going to be the proportional gain, and kind of an adjustment factor based on the systematic error, right? So if it's down and it's down there for quite a bit, you want to just kind of gradually turn up the force until it reaches where you want. So hope that was helpful. That is PI control in a nutshell.